they kind of followed similarly to the plants, so like where there's a high diversity of plants, there's a high diversity of insects, except there's the one habitat where there was one plant that completely got lost.
And let's say monoculture plantations that have been heavily managed with fertilizer use and human disturbance. There's a discrepancy in the microbial function of the area. So our results show that forest, like primary forest has never been touched, and versus oil palm, which is forests have been cut down and replanted, the microbial function is much lower in the soils that have been disturbed, indicating that when you reduce forest cover and you replant these crops for whatever reason, in this case for money for a country, it negatively affects the environment and the soil composition. So it just decreases ecosystem function.
My study was focusing on the environmental history of the platinum group elements, and the platinum group elements were an incredible study topic because they were used in a variety of industries. Some of them were the most important industries in the United States in the 20th century. The examples of that are the primary metals industry, the petroleum industry, the chemicals industry, and they were used in automobile catalytic converters as well. So what we did is we studied the concentrations of the platinum group elements in the sediment in order to track the growth and development of these industries over the course of the 20th century. So we used sediment cores in New York Harbor. New York Harbor was the locus of a lot of these industries. So we used the sediment cores in the harbor to break down and understand how these industries were polluting, what their practices were, and all of this came before the legislature passed the Clean Water Act, which is really when a lot of the data began to be collected. So a lot of this stuff is unknown. A lot of the industrial practices and effluent practices, the pollution practices, are unknown. So we're also getting insight into that in addition to understanding the history of these of the growth of these industries.
Great. So it's the beginning of probably
Yeah, that's the idea. So we developed the method on a core that had already been dated. And my advisor, Steve Shorud, helped me on a lot of the more technical stuff. And yeah, we got back some great results, as you can see.
Great. What was your personal motivation for the project? Did you have any?
Absolutely. So this project, a lot of it is based on my goals for the rest of my life, which are to go into renewable energy and environmental entrepreneurship. So by understanding the growth of innovation and how these industries were utilizing a variety of chemicals and a variety of metals, I was able to get some insight into the history of innovation and the history of economic development in the United States over the course of the 20th century. That caused a lot of the environmental problems that we're now facing in the 21st century, the most important of which is climate change. So by understanding the growth and development of these industries, I was also able to get some insight into why climate change is how it is in the 21st century, and then also understand that in order to change it through renewable energy and environmental entrepreneurship. So that was the chief motivation behind my study.
Great.
I'm Emily Sorensen. I'm a senior at Barnard College. My senior thesis project estimated nitrogen gas emissions from fertilizer use from a development project in Kenya. I wanted to work on this project because I'm really interested in issues of food, and so I found an advisor who was working on a project as part of the Millennium Villages project, which they had an initiative to encourage fertilizer use in order to intensify their agriculture, which means to increase more food. And so I looked at the potential effects of using that fertilizer on climate change because of the emissions of nitrogen that were from the soil.
So what was your senior thesis about, Emily?
I looked at the impact of a publicly traded company's usage of ecosystem services on its price-to-book valuation, which basically measures its stock performance against its assets that are on the books. And so price-to-book valuation is a comparative valuation you can use to compare companies within the same industry. Basically see, who's outperforming the other, absent considerations of size, like market capitalization, or, specific business. So I've used this broad sort of standard market valuation, price to book, and also this measure of profitability, return on equity, compared with different measures of the intensity or efficiency of ecosystem services usage to figure out what the interaction is between ecosystem services and the performance of a public company's stock. So for my initial measures that I use, I only got a couple of significant results, but I used different green rankings, like sustainability rankings, and then a lot of yes or no sort of data, like 0 or 1 on the regressions. Whether a company has considered risks due to climate change or opportunities, or as well as like number of environmental fines paid, just a bunch of measures of kind of corporate governance of sustainability. And there was nothing significant about that. So I also looked at water and greenhouse gas emissions and land as a percentage of total assets. And so I found a significant correlation between price to book versus return on equity, which is profitability, which will correlate with price to book, and greenhouse gas emissions over dollars of EBITDA, which is earnings before interest, taxes, and amortization, depreciation, amortization. And I use that measure because I'm looking at a bunch of different companies from like several different countries. There are different tax rates and interest and different levels of like depreciation, amortization based on the industry and the business. I did look at the impact of industry. I used 4 different industries, and it turned out that there was no significant relationship between industry membership and performance on any of the, either of my significant results. So in summary, I guess I found that there is a negative correlation, price to price to book versus ROE, return on equity, and greenhouse gas emissions per dollar of EBITDA. So efficiency in having like a lower number of greenhouse gas emissions per dollar of EBITDA indicates a higher price to book measure. So it does a company well in the stock market not to emit a lot of greenhouse gases, but energy actually is, priced, unlike a lot of ecosystem services that might be more revealing if I had significant, like land, valued like biodiversity or I guess. And then I found a significant relationship between land as a percentage of total assets and return on equity versus price to book. So companies that have more of their assets represented by land, and this is in value, like historical acquisition cost of land. So it's not a current value. They tend to do better with price to book.
So Sarah, can you tell me what your senior thesis is about?
Of course. So we are investigating which source of organic carbon contributes to arsenic release in the subsurface. In Bangladesh, over 60 million people are exposed to these elevated levels of arsenic in their groundwater, and it can have several adverse health consequences, like arsenicosis, which we can see here, which is characterized by black skin lesions on the hands and feet. And so given that this has some severe health implications, there's a lot of research going into how and why arsenic gets into the groundwater in the first place. And so what we know is that in the subsurface, arsenic and iron are stuck together, and under certain conditions, bacteria will come along and they reduce the iron and release arsenic into the groundwater. These bacteria, though, are heterotrophic, so they require an organic carbon source, and we're trying to figure out, is the carbon that they're consuming, is it anthropogenic or is it sedimentary? And what we found was that these bacteria are using a sedimentary carbon source, which means that this is a naturally occurring process. So there's a lot of speculation about whether anthropogenic activities like pumping, doing a lot of irrigation pumping to irrigate their fields is accelerating. There's concern about whether or not that's accelerating anthropogenic carbon drawdown into the subsurface and making arsenic go into the groundwater. But what we can say here is that this is a naturally occurring process. Anthropogenic activities are not affecting arsenic release. And so people don't have to worry about irrigating their fields and then causing more arsenic release and more arsenic contamination.
Right. So why would you suspect that it's anthropogenic carbon versus natural carbon?
That's a great question. So there are two, because in many sites, anthropogenic carbon, like human waste or agricultural waste that's on the surface, can infiltrate the subsurface. And at some other sites has been shown to drive this release. And that's what made us start thinking, okay, well, is anthropogenic carbon playing a role here at this site where we have a ton of arsenic in the groundwater? And what we think is going on is actually we have a very shallow clay layer that we think is acting as a bit of a cap that's preventing any anthropogenic carbon from getting into the system and helping us get the result that we actually got.
Right. So what inspired you to do this thesis? Did you have any personal motivation in your project?
That's a great question. It's a funny story. I was taking Brian Mayhew's water, sanitation, and health class, and he announced to the class that he's going to Bangladesh in a couple weeks, and he had the ability to take a student. So I said, hey, I'm interested, and he said, well, it would mean you would have to join our project. And I said, okay, let me look into it. I looked into the project. It seemed like it was something that was really worth exploring, and 2 weeks later I was on a plane, and here we are.
Great. Thank you so much.
Thank you.